This video is going to go through a conservation of energy calculation. A rock is thrown straight down with an initial velocity of 12 meters per second. What is the velocity of the rock just before it hits the ground 25 meters below? First, let's write down everything that we know. We know the initial velocity of the rock is 12 meters per second. We will define down as being positive. Because the rock has an initial velocity, that means it initially has some kinetic energy, which we will come back to in a minute. Because the rock is moving in the y direction, the acceleration of the rock will be the acceleration due to gravity, which is 9.8 meters per second squared. This value is also positive since the acceleration due to gravity is acting down, and we already defined down to be positive. We also know the rock is 25 meters above the ground, so this is the height. We are trying to find the final velocity. We can use the idea of conservation of energy to solve this problem. The sum of the potential and kinetic energy before is equal to the sum of potential and kinetic energy after. This means that mass multiplied by gravity multiplied by height plus 1/2 mass multiplied by the initial velocity squared is equal to mass multiplied by gravity multiplied by height plus 1/2 mass multiplied by the final velocity squared. Because there is mass in each term, the mass will cancel out, so the final velocity does not depend on the mass at all. This leaves us with gravity multiplied by height plus 1/2 initial velocity squared is equal to 1/2 final velocity squared. The potential energy term after cancels off since as the rock is hitting the ground, there is no potential energy because the rock is not some height above our horizontal reference line. Rearranging, we see that 2 multiplied by gravity multiplied by height plus 1/2 initial velocity squared is equal to the final velocity squared. After taking the square root of both sides, we arrive at our working equation, which is the final velocity is equal to the square root of 2 multiplied by the gravity multiplied by height plus 1/2 initial velocity squared. Now we can take our working equation and substitute in the values we are given. This leaves us with the square root of 2 multiplied by 9.8 meters per second squared multiplied by 25 meters plus 12 meters per second squared. Simplifying, we have the square root of 490 meters squared per second squared plus 144 meters squared per second squared. This leaves us with a final velocity of 25.2 meters per second. This concludes our conservation of energy example.